All right, you guys have been working on this at the BA class. If you think you're done, start checking the steps. If you're not sure or you're still working, keep going and then come back and check. All right, I'm going to start talking it out if that's okay for you guys. I have it all set up and ready to go. Letter A, why did I, for the leading coefficient test, why did I say n equals 3 and a equals 1, which is positive? What was I thinking? It's odd, which means opposite. And it's going to start from the bottom and end at the top because it's a normal odd function, right? It's not a negative odd function or reflected. It's a normal one. So, wait, is this to the left or to the right? Some of you used words, and that's okay. To the left, what's the function or the y is doing? You can either say negative infinity if you're using the super snazzy notation, or you could use the words. To the left, the function is falling. So to the left, falling. And what's going on to the right? Good. F of x is rising, or we could use the snazzy notation. Did anyone check the odds in the back? There were words, I think. Wasn't the book using words? But I also showed you the notation. Matthew, go ahead. Oh, sorry, Tyler. You were nodding. You had a question.
So you have to look at the x-coordinate too?
Yeah. The leading coefficient tells me whether it's normal or whether it's reflected, but this tells me whether it's same, even, or whether it's opposite, odd. Does that make sense? So think like an x squared is going to behave differently than an x cubed. Oh yeah, that's a coincidence. Because it could have had an x squared and then an x and then a number. You always look at the leading guy.
So even if it was like x cubed plus x squared, you would
Still. Mm-hmm. Just the degree, and the degree is from Algebra 1. The degree is, look at all the terms, it's the guy with the highest.
So the shape of the graph is determined by the degree?
Yes.
Or
Well, the degree is the shape. Leading coefficient is whether or not it's reflected. So think parabola, like a positive parabola, negative parabola. But the behavior of going the same direction as parabola. Does that make sense? Got it. Okay, we already did leading coefficient test, right? So long story short, we know that the function eventually is going to be doing a this and a this at the ends, right? But what's going on in between? I don't know. Big old question marks. We have to keep on going. How many zeros did you guys find?
3.
Good. Did you get x equals -5, 0, and +5?
Yeah.
And so as a result, when you went to go do your table, well, I mean, we could put like a -5 here and a 0. We can already start graphing if you really want to, but we can leave that to the end also. But remember how or what is going in this first column of the table? I'm going to zoom in because it's getting kind of small down there. But you guys help me out. What's supposed to go in that first row, I should say, the first row of the table? Intervals. Good, the x intervals. Not x-intercept, but x-intervals. And here's our test x, and then here's our test y. So we have our test x and our test y. Okay, what's the first interval of this number line, the way it's been broken up? Yeah. Negative forever to negative 5, right? So this first one would be negative infinity to negative 5. What's the next piece of the number line or the x-axis? What's the next piece? Pause, Jason, you're doing an excellent job, but shh. What's the last piece? Positive infinity. So check it. Have I done the whole x-axis? I have this piece, then I have this piece, this piece, this piece. Oh. I have a representative interval for every, well, I have an interval for every piece. Now I need a representative point. I need a test. I need a test point. Let's plug in negative 32. Ew, gross. No. How about negative 6? How about positive 6? It's just easy. You could plug in 7, 10, 12, but you're going to have numbers that are... Ugh. Let's plug in negative 2.5. How about negative 2? Plug in something easy. You don't have to. This isn't a perfect picture. We're not in calculus and doing all these crazy analyses with derivatives to make it perfect. We're just trying to get the idea. You guys have heard the word gist, right? What does that mean? If you have the gist of something. Like the general idea. That's what we want, the general idea. I mean, as specific as possible, but the general idea. Okay, so maybe not as good as our calculator with the max feature and the, well, 0 feature. Hopefully we find the zeros. But maybe not perfect, but the gist. Who's the function? Do you guys want to go all the way back here and plug into the cubic guy? Me either. Can we plug it into this guy? Is that okay? Okay, I'm going to do some mental math. You guys had some time to actually work it out. Some of you, mental math is a horrible idea. You should write it out every time. Let's go ahead and plug in. If we have negative 6 plus 5 is negative 1. That'd be positive 6. And then positive 6 and negative 11. Anybody get negative 66? Nice. I just needed some affirmation to make sure that I didn't do bad mental math. Did anybody plug in 6 and figure out this one's a positive 66? It's not always true, but it is true on this one because the symmetry, if you were to plug in the even-odd symmetry, it actually is all opposite. So what's on one side will be on the other side, the opposite value. But 6 times 11 is 66 times 1 is 66. You could also do mental math. Who chose negative 2 and positive 2 for the test points? Oh, what did you guys choose? Did you do? Oh, negative 3, negative 1. They were good too. I thought halfway and I just went close. Okay, so our numbers are going to be a little bit different, but it should still give us the gist of what's going on. I'm going to plug in my negative 2 real quick. Negative 2 and 3 is negative 6, and negative 6 and negative 7 is negative 40. Oh, positive 42. Thanks, Joe. And then 2 and 7 is 14, and 14, 2 and 7 is 14, and 14 and negative 3 is negative 42. Wow. Guess you don't multiply 3 and 14 every day, huh? What does that mean? I'm kind of going by ones, I guess, a little bit. 1, 2, 3, 4, 5, 6. Yeah, I'm going by ones a little bit. There we go. Negative 6 is way down low. True? Yeah. Negative 2 is pretty far up. Positive 2 is pretty low, but not as low as him. And positive 6 is really high. How does this make sense? I connect with smooth, rounded turns, right? Isn't this one supposed to go down anyway? Oh. It has to go up to the 0 somehow, right? And polynomials don't connect crazily. Isn't it supposed to go up forever? Huh. I think that's what it looks like. What would my calculator say? Not too shabby. Now, I want you guys to actually put it in your calculator, and I want you to find where the actual points are of the maximum and minimum. Because if you had plugged in negative 1, positive 1, guess what? You would have actually ended up sketching something like this. You would have sketched something that was a little bit lower. If you had chosen something like negative 3, positive 3, you would have sketched something like this. So they're going to be a little different. I'm curious what the actual max is supposed to be. I'm curious what the actual min is supposed to be. So use your calculator for that. It's going to probably be something with decimals. We'll see which of us was closest choosing -1, -2, -3. But pause. As you're doing that, don't tell me the answer yet. Guys, is this the gist of the graph? Yeah, I mean, we have the right zeros, we have the behavior, and we know that the max happens somewhere in between. Somewhere in between -5, 0, and 0, 5. Has anybody found me a max? Yeah, there is. I see a max. He's right here. You're going to have to play with your window, right? Because we have big numbers. We have 66, we have 44. You're going to have to make it really high. I wouldn't zoom out or else you're going to squish it in. The x's are fine with -10 to 10, but the y's, I would have it be like what, -100 to 100 or -70 to 70. You need to get some of these big numbers in there. But Jordan, yeah, what's up? There's nothing magical. Just pick one.
Well, I know you can pick whatever, but how do you know to pick ones that would fit the...
Well, these ones literally I'm being lazy and I don't want to have to plug in big numbers. So I'm picking the quickest one I can, the fastest one. Because if I go -7, -8, it's going to be harder for me to plug in. Well, because I don't want to have to cube 7 or 8, I'm going to go with 6. You could have done 10. 10 might have been easier. Because 10 times 15 times 5, maybe that would have been easier in some of your minds. But the bigger the number, usually the harder the math of plugging in. But in here, I mean, my strategy, just personally, is to think halfway and then pick a nice non-fraction number if I can. That's my strategy. But to be honest, some people would choose -1 and 1 because it's faster and easier to plug in, and I don't mind. I wouldn't count you off if you put a -1, 1, or if you put a -3, 3. It's a number. In between, you're using it. Now, they're finding right now the max. What's the x value of the max? 2.5. So, ironically, if we had done 2.5, we would have had this perfect graph. But I don't mind that you're a little bit off and you're using -2, 2, -1, 1, -3, 3. I don't mind. You're getting the general idea, and that's enough in pre-cal. Is that cool?
Yeah, and then the extra stuff, I got those points, for the real.
Yeah.
But how did you, set it up this specific way, negative infinity to -5?
Oh, it was based on what we did yesterday in class when we were doing the sign chart, is what I called it. Because I was talking about, let me dual page real fast so we can compare. We had these zeros of 0 plus or minus 1. And what I showed yesterday was, hey, so the beginning of our graph, not even thinking about the y's, just the x's, these intervals have been split up by the zeros. So I'm going to have a graph coming, I could tell kind of from the behavior of this guy, which was on a different page. I could tell from the behavior which negative leading coefficient and even degree, I could tell it's going to agree going down. I knew it had to come in this interval up to a 0, and then it had to do something around here and go back down. I knew that the zeros split up the behavior of the graph. And I told you guys that in the sense of, I said, use the zeros and how they break up the number line, the x-axis, to make your intervals. So, how is this number line broken up into 1, 2, 3, 4 different pieces? So I need 1, 2, 3, 4 different intervals. And every time you do an x interval, you ask yourself, how left, how right? So here's a piece. How left? -infinity. How right? -1. Here's a piece. What's the left? -1. What's the right? 0. Here's a piece. And here's a piece. That's what we did yesterday. And so in this example, the only thing that changed... Oh, I went too far. Sorry. The only thing that changed was my zeros. So instead of going -infinity to what was -1, now I had to stop at the 0 of -5. Then from -5 to 0, then from 0 to 5, then from 5 to infinity. So I'm just marking down each of the different pieces of the graph.
I was here yesterday, but my mind was
That's
somewhere
I know, I could tell. Okay. Any questions on these? I think this was almost the last type of problem. The last one was this thing that we didn't talk about that I told you could skip in homework, right? Some of you had gone and looked at examples, and that's okay. I just said I wouldn't take off points if you got to intermediate value theorem and stopped. Okay? We're going to talk about him in just a bit after we grade homework all the way up until the intermediate value theorem. But wasn't this near the end? Yeah. Why? Because it put everything together in one big old mama Bahama problem, right? Really quickly, everyone stand up, take your hoods off, turn around 3 times, give someone a high five, say happy Friday, and then sit down and let's grade because people are falling asleep. Let's go. 3 times. Spin. Someone a high five. I share lots of happy Fridays. And then sit. All right, shake it out, and here we go. Number 8. All right, 8, intermediate value theorem. But some of you might have been like, I don't know, we didn't talk about it. Okay, fine. Fill it in now. Number 10 and 12 and 14. Number 10 and 12 and 14 were all matching problems. You can still see number 8, intermediate value. Number 10 and 12 and 14 were all matching problems. F-E-B. F-E-B. Pause. Are you doing your homework correctly and not making me take off points? Do you have little 10 and 12 and 14? And did above number 10 for those 3 problems, did you write something to the effect of matching graphs or match the graphs? I hate taking away points. I'm like, oh. Okay, good. So you have something like match the graphs and then little sketches and the functions that go with them. F and E and B. Number 26. 12 was E. Because if you look at your little sketch, this graph, the reason that they say you're able to match it is because if you did setting x equal to 0, which would be the y-intercept, I think E was the only one that seemed to hit at -4/3. If you peek at the graph, I think E was the only one that hit at -4/3. Number 26, why is it degree 5? Just based on questions that happened earlier today. The highest exponent. Good, the highest exponent is the power of 5. So this would be an odd, which means it would have opposite going this direction because it hasn't been reflected. So it's a normal, like, cubic function. Leading coefficient is positive, the degree is odd, so the graph falls to the left and rises to the right. But those of you guys that were practicing that snazzy notation, just real quick, the other way of writing it, based on what we saw today. Oh, isn't this the exact same as the one that we talked about today? Because as f was going to -infinity, my f of x was falling, and as x was going to +infinity to the right, my f of x was rising. It was the exact same as our opener, as far as notation, because it was odd and with a positive leading coefficient. Okay. It's not surprising if some of you put 3 for the leading coefficient. It's not surprising if you put 3. Just technically you're wrong. Because this whole function has been multiplied by a 1/4. So technically, and this is where kittens die. This is where kittens die. Everybody by that constant. You have to distribute division just like you have to distribute multiplication. So it's really 3/4 x to the 4th minus 1/2 x plus 5/4. Anyway, the leading coefficient, even though some of you might have missed the number, you should have still figured out that it was a positive, right? So even, positive, agreeing, up. Dun, 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 dun. Rise, rise. Or f of x will approach +infinity for both. Jordan. Oh, go back. 26? Got it. What's up?
So, the degree is odd, so
Opposite.
yeah, so it's opposite there, and then because the leading coefficient is even, it just means that it's not.
Oh. Has nothing to do with even or odd leading coefficient. It has to do with positive or negative.
Okay, oh, so the number technically doesn't.
It has no bearing besides like how stretched it is, but other than that, no.
Okay, so it's only like, okay.
Positive, normal. Negative, reflected. Yeah, there you go. Okay, zoop, zoop. Number 36, plus or minus 9. Which, if you guys had, sorry for letter A, for the zeros. If you guys had subtracted the 81 divided by a negative, you should have plus or minus square rooted, square root of squared. But you could have also, I would have said factor, 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 and you would have found both of them. Why does each 0 have a multiplicity of 1? Do you remember from yesterday what multiplicity is? Good. Each factor has an exponent of just, no one was squared. Okay, but that's the degree. When you factored, each one just had a power of 1. That's why multiplicity of 1. Which meant in the graph that you cross through each of those. Turning points, well, it's a parabola. There's only one turning point. From going up to going down, one turning point. A smooth curve. And then they let you use your graphing calculator? Psh, spoiled rotten. You guys should have known that. It was an x squared reflected down, up 81, right? Mm-hmm. Okay, let me give you a second. The opener was number 75. This is number 76. Here's the A, the B, the C, the D, like you guys did at the beginning of class. So check it out. Maybe you were stuck last night, but from the opener, do you now know what they did? What's the behavior based on the degree of 4 and a positive leading coefficient? What were the zeros based on the factoring? Hold on. Do I like their sign chart? No. I do not like their sign chart at all. So, just because it's on CalcChat doesn't mean it's good. Ooh, that's not the custom pen I want. Hold on. Ugh. Why is it blue? Struggle. Okay, what would I say is better? What should your first column be? X intervals. Based upon, how do we get X intervals? Okay. So I'm going to add a third column. I don't want that anymore, though. What would you guys say were your columns for this problem, based on the zeros? Negative infinity to negative 3. Then? To 0. Good. Then? Good. Then? They even did more than they were supposed to. Forget that. We don't need that extra point. We just need 1 for each interval. So we have our test x and our test y. Based on what we did together in class, guys, what's a good value of a test x? -4, yeah, I think that's exactly what I would have chosen. Like the quick, short, simple. Some of you might have liked plugging in a 5 better. It's up to you. What do you think, -2 or -1? Let's be lazy. Is that okay? We'll plug in a 1. That's easier. Any mental mathers available? Your brain's awake in order to double check my math? I see a 16, I see a -16, and I see 16 and 7 would be 102? Oh, 112, thanks. So close, and yet so far. And it was times a -7, right? Yeah, so my positive was good. Okay. Plugging in -1 is so much easier. That's 1 times 2 is 2 times -4. I think it's -8, yeah? And then 1 and 4 and -2 is also a -8. And then plugging in a 4. Oh, look, symmetry. If I plug in a -x, nothing changes. So I can just steal it, and then I can just steal it. Sweet. My life is easier. And I could go ahead and plug the 0, 0. I would graph 0, 0, graph -3, 0, graph 3, 0, graph -1, -8-ish, graph 1, -8-ish, graph 4 being super high, graph -4 being super high. And then I would have swooped. There it is. Was I perfect? No. The gist? Yeah. Technically, the minimum would have been somewhere in between here, and it was. It's around, I think, negative 1.8-ish. Actually, once you learn to do calculus, it's not really that bad to find it. You guys probably have no idea what I'm doing, but that's totally okay because you don't need to yet. Ooh. Huh. Oh, it's a positive. That's what's wrong. There we go. The maximum mins would technically have been at, you guys can check it out, but actually the maximums and minimums happen at 9 over 2 square rooted, which would be somewhere around 2 point something. 2 point something. Negative 2.1-ish, 2-ish, and positive 2.1-ish, 2-ish. You could plug into your calculator. That's the exact spot, but you can't do that without calculus, so bummer. For right now, we just say, good enough. Good enough. So then coming back to homework. Ooh. I want you guys to go ahead and 94 was the one you did not have to have done for today. We're going to go ahead and go over questions that you might have on homework up to intermediate value theorem, but not including it. Anything before number 94 that you guys want to ask about on homework. Which one? Oh, no, Lauren. Yes, you may. No questions before 94? We all got stuck in the same place? How many of you guys would say that the opener today kind of helped a little bit? Okay. Okay, so maybe that's why we're doing okay. Perfect. Let's go ahead and talk about the intermediate value theorem. Guys, tomorrow, Monday, we will go over 94, and I'll let you guys see it. But for right now, let's just finish our notes on intermediate value theorem. Let's go into section 2.3. And then we'll kind of check that final homework problem that some of you didn't even touch, and that's okay. Do it over the weekend. That's all right. I told you were allowed to stop and not have to use the book. That's why we're in regular, not honors. Yeah. Don't get lost, though. Okay, this is still section 2.2. Remember, we didn't get to finish notes yesterday. This is still section 2.2. We didn't get to finish notes. So we're finishing 2.2. You guys can finish up that last homework problem, and then we're starting 2.3. So here we go. Intermediate value theorem. It was vocab number 6 something. Let me give you a second, and then I'll talk it through. The idea is actually pretty basic. Just has a really snazzy name to it and has a lot of applications that you'll hear from time to time during the year. The height example, I'll give you that in a second. No luck? All better. What you guys are writing is the name, intermediate value theorem. The application, a continuous function, must have a 0. AKA an x-intercept. Just reminding us real fast, even though we've seen the word 0 since the first week of school in the graphing calculator, but 0 is the x-intercept. A function will cross the x-axis if its y's go from positive to negative or negative to positive. A continuous function. If it's not continuous, no, all bets are off. Who knows? Maybe, maybe not. It could jump. It could avoid the x-axis. But any continuous function, aka a function that can be drawn without picking up your pencil, no jumps, no vertical asymptotes, no holes. A continuous function must go through the x-axis whenever its y values switch from positive to negative, or vice versa, negative to positive. Here's my height example. Did I used to be 4'8"? Yeah. Why? Well, how do you know that I had to go through 4'8", though? because I'm taller than 4'8", and when I was born, I was less than 4'8", right? A lot less. So was I 5'2" at some point in my life? 5'5"? Whatever height you are right now? Yeah, I've been all of your heights, right? I'm 6'2" right now. Around then. I haven't measured myself since high school basketball, so I'm not sure. But I kind of avoid it. But it's okay. God made me the way I am. My mama liked it because I could always reach the high stuff on the cupboards. But I had to be 5'10". I had to be 4'8". I had to be 5'2". I had to be 5'4". I had to be whatever height you are. Because height is a continuous function. And I was born really small, and now I'm really tall, and I was everything in between. That's all this is. I was everything in between. What's intermediate? In between, right? Beginner here, advanced here, intermediate, it's in between, right? Value. Function value. Ever since the first week of school, function value are the y's. So there's an in-between y value guaranteed? Yeah, for any continuous function. So if I know it's here and I know it's here, what did it have to do somewhere? It had to hit it. Now, could it have hit it a few times? Sure. But it had to hit it at least. We're building up to this section called 2.5, zeros of polynomial functions that are gross, that are nasty, and that don't have GCFs. Oh. What was nice about homework last night when you went to go factor all these nasty 4th degree, 5th degree cubes? They all had GCFs that would come out and leave behind little quadratics, right? In section 2.5, there are no GCFs, and they're nasty quartics and quintics and cubics. And so this is going to become helpful or be helpful later on. But for right now, this homework, just number 94. Did I give you more than one or just one? Just one? Well, that's not bad. Let me show you the idea, and you can write down whatever you want about it. Okay? The idea of number 94, which is, number 96. You have a function. Every polynomial is continuous, every single one. So, does this guy have to have a 0? In general, no. Can't I draw you even a messy 4th degree polynomial that doesn't have a 0? He doesn't hit. So Joe, why did you say that he doesn't have to have a 0? Because you thought of this kind of thing, right? But hold on. This function, does this function have to have a 0? Let me show you something. Ready? What if you plug in 0? I'm making up some numbers. What if you plug in 0? It's a positive number, right? Yes, it's 3. It's positive. What if you plug in 1/2? Now, some of you don't like 1/2. But if you plug in 1/2, the positive is really small, and the 3 is pretty small, and what's this? Well, I would get 1/8, no, 1/16, right? I'd have 1/16, which is a positive, and then I'd have minus 10 times 1/4, and then I'd have plus 3. Isn't that negative 2.5? Oh, that's a positive also. Maybe it doesn't have any zeros. Wait, what if I was to plug in something that maybe was just a little bit bigger? What's something a little bit bigger than 1/2? I could go 1, but 1's a positive also. That doesn't help. I need this number to be stronger than either of those two numbers, right? What if I was to do something like 2/3? I know it's not happy. I know no one likes that number. But 2/3, that would be 16/81. Double check me. 3 and 3 is 9. 3 and 3 is 9. 9 and 9 is 81. 2/3. 4/9 plus 3. Is that any better? What's 40/9? As a mixed number, just as an approximation. What's 40/9? Almost 4. Wait, almost 4?
It's more than 4.
Oh, that's a negative. What did I just show you? This guy has to have a 0. He's not going to be like that. He has to have at least one because sometimes he's positive. Normally he's positive, but sometimes he's negative. Now, the nice thing is your homework doesn't make you come up with this. It lets you use your graphing calculator. So really quickly, we just need to review a couple things from our handbook. And if you have your calculator, grab it out real fast. If you have your calculator, grab it out real fast. Guys, we need to go to a table. Plug this function into your table. Or if nothing else, just to review, can you guys find where table setup is? Where's table setup? Second window, good. Second window. So if I was to put this function into my calculator, I'm just reviewing really quickly a couple things in our calculator. We could, let me get rid of all that, that's calculus. We could change our table and we could say, hey, table, sometimes I want them to go by ones. Do you remember which one has it going by ones? Now, first of all, going by ones, I need it to automatically generate, so I'm going to change it from ask to auto. This little triangle would have it going by ones, or I could have it going by 0.1s, or I could have it going by, in the next part, 0.01s. Here's what ends up happening. Oh, it's gone. Oh, that's so sad. Well, it wasn't there. That's a bummer. Sorry, in years past, I'd actually had it ready so you guys could see it. That's okay. Let's put in our function really fast. We have x to the 4th is 10x squared. Yeah, I know, huh? It got deleted or disappeared or something or others. Plus 3. We have our table set up going by ones. How do I know this guy has a 0? Ooh, I'm not going by ones first. You guys see the shortcut for going by? You can hit the little plus sign. But I don't think I'm having it start at 0, am I? Let's have it start at 0. There we go. Are there zeros? Yes. How do I know? Because there's a sign change. So I can actually steal that, and I can say, yay, there are zeros. Where? Well, there's going to be a 0 at least right there in between 3 and 4, and at least right there between 0 and 1. But how can I get even more precise? Well, instead of going by ones, look, shortcut, I can go by 0.1s, and I can say, well, I need to get a little bit more zoomed in. No 0, no 0, no, there's a 0. Do you see it? So I could zoom in even closer and I could say, oh, you know what? Not only do I know that there's 1 in between 0 and 1, if I go just a little bit more zoomed in, I know there's 1 in between 0.5 and 0.6 because of that sign change. And not even that, I could go ahead and go down to this 0.5 and I could say now I need to go by 0.01s. And I could see not only is it between 0.5 and 0.6, I can also say it's between 0.55 and 0.56. And how am I doing all this math? By looking for sign changes. And what was the point of looking for sign changes? Just applying the intermediate value theorem and seeing maybe how your calculator finds the zeros it finds. But what is your graph able to do for you? Yeah. So you're going to use a table to try to get as close to a 0 as you can. Maybe even make a guess based on the numbers that you see. I see it a little bit, I think, closer to this guy. So I'm going to do something like 0.557 maybe. And then go to your graph and actually use the feature and see how close your guess was based on the table work. That's intermediate value theorem. If you see a sign change, a 0 has to be guaranteed. Kiddos, we're not going to get very far in section 2.3, but it's okay because it's not a long section. The homework is due on Tuesday, so we'll have Monday to finish it up. But I want you guys to at least get down what the topics are, because the topics say we're building up to the section 2.5 guy that has really nasty problems without GCFs, or I should say really nasty polynomials that we'll have to factor without GCFs. So we need to do section 2.3 that says, hey, let's practice some long division and synthetic division. Because if polynomials are hard to factor, we're going to have to learn or remember how to break them down. And the first step to breaking them down is division. So synthetic and long division. The first step to breaking down a polynomial is division. And maybe, just maybe, a few of you guys remember that if you have a fraction of functions, you can put the numerator in the box, leaving zeros for missing pieces. You can put the denominator outside, and you can actually look at the leading terms and say, how many times do you go in? And then do this little distribution. And on Monday, we'll keep on reviewing the division. Jason, pause. We'll keep on reviewing the division so that you guys will be ready, more ready, for homework due on Tuesday. Bye, guys. Have a great weekend. Football players, have a great game tonight. People traveling to the game, prayer safety traveling. Go cheer them on well.